Hey guys, welcome to my first video. I'll be talking about grade 7 math and just explaining some concepts that you might not know. In this video, I'll be talking about the lowest common multiple and the greatest common factor. I'll be explaining what they are and how to find them in a reliable method. However, first, I'll just a recap of knowledge. Composite numbers is a number that can be created by multiplying two smaller integers together. For example, 14 and 21. 14 by multiplying 2 and 7, and 21 by multiplying 3 and 7. However, prime numbers is a number that cannot be split into two smaller integers. For example, 2, 3, and 7. The lowest common multiple. It is the smallest integer that can be created using the initial integers when they are multiplied by another integer. I'll repeat that. It is the smallest integer that can be created using the initial integers when they are multiplied by another integer. Just to explain this, because it might be hard to understand, I'll be giving an example. The initial numbers, or the numbers that you're given in the question in this case, would be 4 and 6. You can multiply 4 by another number, 3, and 6 by another number, 2, to find the answer 12 that they both can make. In this case, 12 would be the lowest common multiple of 4 and 6 because it is the smallest integer that can be created by them when they are multiplied by another number. What is the greatest common factor? Well, it is the largest integer that, when multiplied by other integers, can then produce the initial integer. I'll repeat that again. It is the largest integer, meaning the answer, when multiplied by other integers, can then produce the initial integer, which is the numbers that you're given. In this case, let's say you're given 4 and 6. The greatest common factor is 2, because as you can see, you can multiply 2 by itself to make 4, and 2 by 3 to make 6. So therefore, it is the greatest common factor of 4 and 6. However, what is the difference? It might be pretty confusing since they both sound very similar. However, they still have very different meanings. For the lowest common multiple, the initial numbers are being multiplied by another number to produce the answer. However, for the greatest common factor, the answer has to be multiplied by different numbers to then produce the initial numbers. The initial number would be 4 and 6, and you can see that they would be multiplied by another number to then produce the largest common multiple. But then, as I said before, the initial number, 4 and 6, can have the greatest common factor, which is 2, because 2 can be multiplied by other numbers to then create the initial number. How would you find the lowest common multiple? Well, firstly, you would list the prime factors of each initial number. Then you would find the most amount of times a factor has been used in an initial number. Lastly, you would multiply all the highest amount of times a factor has been used together. This might seem hard, but it's actually very easy in practice. I'll be using the same numbers that we've been using before, which is 4 and 6. And as I said before, we'd firstly list all the prime factors of each initial number. Prime factors of 4 would be 2 and 2, and the prime factors of 6 would be 3 and 2. Then you can list each factor into a chart to make it easier to find the next step, which is to find the most amount of times a factor has been used in an initial number. Well, for 6, it has 2 factors, 3 and 2, both occurring once. However, for 4, it only has one factor, 2, but it occurs twice. This means that we can move on to our third step, which is to multiply all the highest amount of times a factor has been used together. There are 2 different factors overall, 3 and 2. However, 3 occurs once, which is more than the amount of times 3 occurs in 4, which is 0 times, meaning that we would use 3 once. However, we can see that 2 has been used for both 4 and 6. However, since we only want the highest amount of times a factor has been used in each initial number, we would only use two factors, two twos, more than only one 2, because 2 is higher than 1. So therefore, we would come up with the answer 3 times 2 times 2, which is 12. An easy way to think of this, just to understand the concept and why we do it this way, is that the amount of times a factor is used is the least amount of it to satisfy the creation of either or both numbers. Basically, the lowest common multiple would be the smallest number that can be created using both of the numbers. Therefore, if we already have, for example, 2 2's in number 4, we wouldn't need another 2 from number 6 because it already applies and within that only single 2. Therefore, we wouldn't need 3 2's, for example. Moving on to the greatest common factor, this is similar, but the last step is a little bit different. Again, you would list the prime factors of each number, as we've done before. We would then list the individual factors each number has in common, rather than which factors each number has the most, and then we will multiply them together each time that they have in common. Just to simplify what this means, you can see that 6 has 3 and 2 once each. However, 4 has 2 twice. We can see that the only factors that they have in common is 1, 2, because although 4 has the factor 2 twice, 6 doesn't have 2 2's. However, they both only have 1 2. This means that although we would multiply all of them together, we only have one factor they have in common, which is 2. So therefore, we could see that the greatest common factor is 2. How does this make sense? Well, this means that what factors both only have in common is to find the greatest common factor, meaning although both have different factors, we can see that the greatest factor can only be the ones they have in common multiplied. Now that we've finished some easier examples, we can move on to harder examples. Although this can be done using the same steps, principally is the same difficulty. However, this only expands using more numbers. You can do this on your own first, using the example with two numbers, 20 and 48. And you can pause the video right now to do it yourself. Alright, assuming that you've already done it, we can go through it together. What factors does 20 have in common? Well, you can see that 20 can have 3 factors, 2, 2, and 5. This is because although it can be put into 4 and 5, 4 isn't a factor, and it can actually be factored down even further into 2 2's. In the same case of 48, however, it's just a larger step. You can have 4 2's and then 1 3. As we've done before, we would put both of them into charts, and we can see that for 20, it has the factor 5 and 2, 5 occurring once and 2 occurring twice. 48 has the factor 2 and 3, however 2 occurs 4 times and the factor 3 occurs once. To find the lowest common multiple, as we said before, we would find all of the factors that exist and then find the most amount of times it has been used in either number. There's 3 factors that exist within this whole example, which is 5, 2, and 3. However, the most amount of times 5 exists is in 20, which is once. 2 occurs the most amount of times in 48, which is 4 times, and 3 occurs the most in 48, which is once. Therefore, we can multiply 1 5, 4 2's, and 1 3 together to find the lowest common multiple, which is 240. However, for the greatest common factor, it is a lot simpler. We can see that the only factors that they have in common are 2 2's. Therefore, you can multiply 2 by 2, and therefore you would get 4, which is the greatest common factor of 20 and 48. That basically concludes our lesson on the greatest common factor and the lowest common multiple. I'd appreciate it if you guys liked the video, and you can give me feedback on what else you would like to learn, and I'll do my best to accommodate your needs. Thanks.